Hello everyone, welcome to Physics Council. Today I am going to discuss one of the topic in basic mathematics, that is differentiation. So differentiation means rate of change of a quantity. Rate of change of a quantity. And nothing but in graphical representation we can say, so that is a slope, or we can say derivative, So now I am going to explain these terms with the help of a graph. So let me take a graph here. So this is y versus x graph, and here this is a straight line. So on this straight line I am going to take a 2 points here. So this is coordinates are x1 comma y1, and this, and the second point is this, and coordinates are x2 comma y2, isn't it? And this is a q point and this is the p point, right? So now, and this line is making an angle theta with the horizontal, and now so from here to here that is a x1, and from here to here that is x2, and in y-axis that is this is a y1 and this is y2, isn't it? And change in y, and change in, this is a change in y and this is a change in x, and change in y is a y2 minus y1 here, and this is a x2 minus x1 here. So now if it is theta, and this is also a theta, isn't it? And now so line equation is, already we know that is a y is equals to mx plus c, isn't it? And in this c is a constant, nothing but y intercept, and this is m means slope. M means nothing but slope. So here slope is nothing, slope means, so m means slope, which is equals to tan theta, and tan theta is nothing but opposite by adjacent. So from this triangle, opposite by adjacent, so which is equals to y2 minus y1 by x2 minus x1, that is equals to, so we can write it as delta y by delta x, delta y by delta x. So now this delta y by delta x will gives us average rate of change, will gives us average rate of, right? So average rate of change. Now when this q point is approaches to p point, nothing but, so this is when x2 approximately equals to x1 but not equals to x1, approximately equals to x1. So in that case, when, so here I am going to write, so this is, I am going to erase this, when delta x tends to 0, nothing but x2 minus x1 tends to 0, so delta y by delta x, we can write delta y by delta x as dy by dx, dy by dx, and this dy by dx will gives us instantaneous rate of change, instantaneous rate of change, nothing but, so dy by dx means slope of y with respect to x, or rate of change of y with respect to x, or derivative of y with respect to x, like that we can, isn't it? So now I am going to conclude this with the help of a curved line. So let me take the curved line here. So again here I am taking xy graph, and this is what the curved line, and this is a point, this is one point and this is another point. So coordinates are x1 comma y1 here, and the coordinates are x2 comma y2 here, and when this q point is up and this line joining between these two is, so that is what we call secant line, isn't it? That is secant line. When that q is approaches to p, approximately approaches to p, so now this secant line convert to what? This secant line convert to tangent line, secant line converted to tangent line. This is what a tangent line, right? So this secant line gives us, so that is a delta y by delta x, so which will gives us average rate of change. And when this secant line converts to tangent line, so that is what we call, that is dy by dx, which will gives us an instantaneous rate of change, isn't it? Which will gives us instantaneous rate of change, right? So now, so finally I am going to conclude that, so when if y is a function of x, then limit of the ratio, then limit of the ratio of change in y to change in x is called derivative, as delta x tends to 0, and the process of finding the derivative, is called differentiation, right? The process of finding the derivative is called differentiation. So now, so let me give you some examples. So for example, v is equals to ds by dt, nothing but, so derivative of position with respect to time is called velocity, which will gives us an instantaneous value. And next thing is acceleration, so which is equals to, so dv by dt, derivative of v with respect to t, or rate of change of v with respect to t. So here the rate of change of position with respect to t, with respect to time. So that is what meaning of this. So which will gives us instantaneous value, right? So this it is instantaneous value. So let me give you some formulas, differentiation formulas. So now first one is d by dx of constant is equals to 0. d by dx of constant is equals to 0. And the second thing is d by dx of x is equals to 1, and d by dx of x power n is equals to n into x power n minus 1. So here fourth one, d by dx of log x is equals to 1 by x, d by dx of log x is equals to 1 by x. Next one, d by dx of e power x is equals to e power x, right? So next, d by dx of sin x is equals to cos x, d by dx of cos x is equals to minus sin x, isn't it? And next, d by dx of tan x is equals to secant square x, isn't it? And next one, d by dx of y square, d by dx of y square. So here, for example, sorry, wait a minute. So these formulas are enough to solve the physics problems and understanding the physics concept, isn't it? So now let me take some examples here. So for example, d by dx of x square is equals to nothing but, so derivative of x square with respect to x, derivative of x square with respect to x, nothing but n into x power n minus 1. So that is n into x power n minus 1 means that is 2x, right? N into x power n minus 1, 2 minus 1 means 1, that is a 2x. So d by dx of x cube is equals to, that is 3x square, n into x power n minus 1, isn't it? So now, so take a screenshot. And next one is, for example, so if d by dx of y square is equals to, and if you observe this fashion, so here derivative of sin x with respect to x, derivative of one quantity with respect to the same quantity, isn't it? So that is what we need to understand here. This here we have a same fashion, and the fashion will be different here. So derivative of y square with respect to x we need to do, right? Derivative of one quantity with respect to another quantity, isn't it? Right. So that is the thing we need to observe here, right? So now, so in this case, first of all, we need to take y as a x, right? So in first case, with respect to y, we need to differentiate this y square, nothing but, so that is a dy by, so that is a 2y, right? dy by dy of y square is a 2y. So now, so this y we need to differentiate with respect to x, so that is a dy by dx, that is dy by dx. So like that we need to differentiate again. So for example, dy by dx of e power u, right? So actually d by du of e power u formula is e power u, and here we took u as a x, so that u we need to differentiate again with respect to x, so that is a du by dx, right? So this is what we call, this pattern is what we call chain rule, isn't it? So these formulas are so enough to solve physics problems and understanding the physics concept. Okay, so please note it down. So let me take some example. If y is equals to 3x square plus 2x plus 1, like that they have given. So find out dy by dx. So nothing but, so here d by dx of y means 3x square plus 2x plus 1 here, isn't it? So first of all we need to split. So d by dx of 3x square, d by dx of 3x square plus d by dx of 2x plus d by dx of 1, isn't it? So here 3 is the constant and 3, 2, 1s are a constant. So this is a x, here x square multiplied by 3, isn't it? So this 3 is we need to write outside of the differentiation, and so why? Because this is a numerically constant, we need to write outside of the differentiation. And d by dx of 3 into d by dx of x square plus 2 into d by dx of x, isn't it? Next plus d by dx of 1, d by dx of 1. So already we know that. So d by dx of x square means it is in the form of x power n, isn't it? That is the formula is n into x power n minus 1, isn't it? So that is a 3 into 2x. 3 into 2x means which is equals to 6x plus, so d by dx of x is equals to 1, already we know that. So that is a 2 plus d by dx of 1 is a constant here, so d by dx of 1 is equals to 0, isn't it? So that is a 0. So the final equation is 6x plus 2, 6x plus 2. So like that we need to differentiate, isn't it? So one more example. So that is d by dx of 2x cube plus 3, right? So write the answer and place in comment box. Okay, so now next thing is d by dx of t cube, d by dx of t cube. So this is, so here we need to apply chain rule. So first of all, with respect to we need to differentiate the t cube. So nothing but that is 3t square, isn't it? So again t we need to differentiate with respect to x, that is dt, which is equals to dt by dx, isn't it? So this is what the differentiation of this, right? So take a screenshot.